number 2 from 2018. So it says a particle moves along the x-axis with velocity given this way. T goes from 0 to 3.5. And then particle is at position x equals -5. So this is the initial condition here. Find the acceleration. So how am I going to do this one? Using the calculator. So what I'm going to do is on the y sub 1, I'm going to put this function. So second alpha, okay, 10 sine of 0.4 x squared, and then x squared minus x plus 3. So that's the function that I have. And then acceleration, as you know, is the derivative of the velocity. So what I'm going to do is I'm going to do math, and then number 8, derivative against x, and then there will be y sub 1. And x value is equal to 3. Then negative 2.118. So here we get a of 3 is equal to v prime of 3, which is equal to 2.118. Alrighty. Now find the position. And when t is equal to 3, so then how do you find the position? Because we are starting from -5. So what I'm going to do is I'm going to start from -5 and plus. Now I'm going to position is the integral of the velocity. So what I'm going to do is I'm going to go for math number 9. Because the initial time was equal to 0 till 3, and then y sub 1 and x. So when I calculate this one, negative 1.760 must be the position. So here we get what I have to do is -5 starting from here plus, because integral only gets the change in positions, so 0 through 3. So I'm starting from -5, but the change is from 0 through 3 of v of t dt, and we realized that that was -1.760. So that would have been my answer. Evaluate this one, and then evaluate this one, and then interpret the meaning of each integral in the context of the problem. So here we get math number 9 integral from 0 through 3.5. First one is just v of t. That means I'm going to type in y sub 1 and then dx. Then it was equal to 2.844. So 3.5 v of t dt is equal to 2.844. And then we realize that that's the change in displacement. Okay, so this represents a change in position or displacement. Let me just write it down this way, then displacement of the particle from t equals 0 to t equals 3.5. So that's basically what we end up getting. Now let's do the second part here, and then I'm going to write down the solution. 0 through 3.5, absolute value of v of t. You see, absolute value talks about the speed. So when what I'm going to do is I'm going to copy this one, and I'm going to plug in second insert math number absolute value. There it goes, and then here y sub 1, and then I'm going to delete that one. So in this way, Now what I have here is the integral of the absolute value. Then absolute value of the velocity is the speed, so what we end up getting is the total distance it traveled. So it's 3.737 is the what? Distance that the particle traveled from t equals 0 to t equals 3.5. So difference is displacement versus distance. Alrighty, let's look at number D here. The second particle moves along the x-axis with position given by here, okay? At what time t are the two particles moving at the same velocity? So that means what I'm going to do is I'm going to take the derivative of that, which is velocity of the second one is 2t minus 1. So what I'm going to do is I have to just set them equal to each other. So x minus 1 in my case. And then I'm looking at time from 0 through 3.5. So I'm going to set the window 0 and then 3.5. And zoom fit, which was number 0. So you can see that there's one intersection. So what I'm going to do is second calc intersect number 5. Bam, bam, bam. All right, 1.571 if you round it. So v of t, v sub 2 of t has to be equal to v of t. And then t was equal to 1.571 rounding. Alrighty, so that's how we can do number 2. I'll see you at number 3.